mess in this attic. Lot going on, but there ain't no need to panic. Come on up and join, we getting wild, getting manic. Spitting truth for all you fanatics. Every week got something new to say. Ain't no filter, this shit coming straight from the brain. It's coming straight from the brain. Yeah, it's coming straight from the brain.
What's up, everybody? This is A Talk in the Attic. This is your host, Kirk Ross. We got a special one today. We're going to take you into a deep dive into deep space with my main man from NASA, Kevin Rainbolt. We're going to talk about the James Webb Space Telescope. So enjoy this one. We're going to look at some beautiful imagery. Check this one out on YouTube. Thanks for checking in. We'll see you soon. Thanks, Kevin. Let's learn about some space, people. Okay, folks, I'm back here with Kevin Rainbolt. You met him a few episodes back. Go down to the show notes to see his full interview where we talk about all sorts of NASA-related things and Kevin's background a little bit. Kevin, welcome back.
Thank you. Appreciate it, Kirk. Good to be here.
So I had you back because the James Webb Space Telescope, which you alluded to on your interview,
Yes.
that thing has launched, and these images are just like breathtaking. But they're also really hard to understand what we're looking at, so I wanted to bring you in so you can educate me, frankly, and everyone watching and listening. This would definitely be a good one to watch, folks, because while you're hearing us talk, you'll see a lot of the actual images that we're talking about on the screen, so it'll obviously make it a more enjoyable experience. But if you are just listening, thanks for listening. I'm sure you'll still get something out of it. Kevin, all right, take it away, baby.
All right. So the James Webb Space Telescope, like you said, I alluded to in our last meeting, we discussed a little bit in our last podcast. It is a space telescope. So it's a spaceborne telescope that was launched on Christmas Day last year. It's been in development for nearly 25 years, finally launched at the cost of $10 billion. And it took about a month or so to get to its point in space. So it's about 1.5 million miles away from Earth right now. No hopes for it. If anything goes wrong, it'll just become space garbage out there. So if we really hope things go right, and so far they have, which has been so exciting. So this first image here is the deep field photo that was released back on July 11th. And this is a photo that shows nearly countless galaxies. You can kind of see it has sort of a circular appearance to it. There's a few galaxies that are kind of spread in a ring around the center of this photo, but every little speck and dot that you see on the black backdrop here is a galaxy that's billions of light years away. Now you'll see a few stars in this image that are actually close to us. They're within the Milky Way, and you can tell those because it has these diffraction spikes on it, and you'll see 8 little spikes coming out of those stars. So those can kind of be ignored because those are within our galaxy, but everything else is a separate galaxy that's billions of light years away. And what's really cool about this photo, there's a couple things. One is that as I mentioned, there's this like halo effect going on, and what's happening there is called gravitational lensing. Yeah. Gravitational lensing is where a very massive object is actually bending the light around it. So we're seeing stuff from one side of that large massive object bending around the light bending around it and coming back to us. And so we're seeing that like smearing effect of a ring around a very large cluster of galaxies.
Holy smokes. So is there a number that you all have come up with that you think is depicted here in terms of how many are visible?
Oh, I'm not sure, and it's kind of arbitrary because it's really just the size of the field that this happened to be taken from, and like to get a rough estimate to understand the size of the piece of sky that this is looking at. It's like if you would take a grain of sand and put it on the end of your finger and hold it away from you and hold that up into towards the night sky. That's the total size this image is capturing. So just that one little speck of sky is thousands of galaxies. The other thing that's really cool about this photo is that there are a few very red specks in here, and some of those have been determined, or we're expecting those to be more than 13.5 billion years old. Now, the galaxy is only 13, or the universe is only 13.8 billion years old. So these are the very, very first galaxies to form, and they're actually kind of making us rethink about stellar and galactic formation, because we didn't expect them to exist this early in the universe. So it's really fascinating stuff. There's so much science that's coming out of this literally every day that in 2 weeks, we're going to know more about this than we do right now.
I mean, so what? Okay, so just I know this is like a theoretical thing, obviously, but what was going on before 13.8 billion years ago?
Yeah, that's a great question. For a long time, scientists just said, well, it's probably more of a philosophical question than a science question. These days, there are some ideas about maybe what happened before the Big Bang. Of course, the Big Bang is what we all now know and expect to be the beginning of the universe, where a massive singularity exploded, and the universe inflated at an extremely rapid rate. And 13.8 billion years later, here we are. Prior to that, it's hard to know for sure. There's some thoughts that maybe another universe existed before it, and then ours was born out of some singularity from that previous universe. There's other thoughts that maybe there's some sort of multi-dimensional thing going on where we potentially collided with another universe. There's so many things, but it's very hard. Time as we know it was different at that point in time. And so it's hard to say what happened before or after, because time really didn't exist in the way that we experience it now.
Yeah. Okay. So this swirling that we're seeing. I know you mentioned like you sometimes you see the large clusters, but that swirling is what showing like the E equals MC squared concept or something, or what?
It's a little bit. So it is kind of the there's some relativity going on here, which is basically saying gravity is so strong that it can bend light when gravity is large enough. So when we have these large galactic clusters that we're looking at in the middle of this photo, it's so heavy that the light from more distant galaxies behind it is bending around that cluster and coming back into our eyesight. So sometimes we'll see it come from both sides, and you'll get this like ring effect around these very heavy objects. It's a really fascinating phenomenon that does relate to relativity.
That's just yeah. This is crazy. This was mind bending. This is the first one that came out, right?
That's correct. Yep.
This is called the deep field image.
And there is a similar one that Hubble produced of this same area. And so you can kind of compare the two and see how much more like detailed the James Webb photo is. And also the James Webb photo took like 1/20th the time that it took for Hubble to capture this. This entire photo was captured in only a 12-hour exposure, which is substantially less time than what Hubble takes. So that's another huge advantage to James Webb, is that it can just do science so much faster.
And so you're saying this is only a grain of sand amongst the infinite sky. So is the intention for James Webb to take more snapshots of this, like in a 360 kind of, or to get a wider view, or is there enough to be gleaned from this that it's not necessary at this point?
I don't think that there's intentions of trying to map the entire sky's deep field like this. It would probably take the entirety of James Webb's lifetime to do that. Instead, they'll probably do that in a few different areas that we're interested in. But a lot of what James Webb is here to do is, do other science, like looking at potentially other planets from other solar systems, or deep galaxy, like specific galaxies and things like that, versus just taking random snapshots. But there's so much science from anything that it does, so everyone's just like excited about it.
Yeah, this is cool. All right, you got me excited. Let's move to the next one.
Sure.
Let's go to the Stephan's quintet.
Stephan's quintet, sure. So the Stephan's quintet is a galactic supercluster. It's probably the most famous and well-studied cluster. It is actually 4 galaxies that are sort of in gravitational lockstep with one another. Generally speaking, galaxies are kind of off on their own, doing their own thing. They've collected all of the matter around them, and so they're kind of just living on their own in space. So to see two galaxies interacting with each other is pretty special, but having 4 of them interacting with each other at once is very rare, and it's relatively close to us. there's actually, if you look in this photo on the left side, there's one that's slightly more clearly depicted, like you can pick the stars out of it. And that's actually substantially closer to us than the rest of it. So it's kind of an interesting depiction of how, from our perspective, since we don't have any sort of parallaxing capabilities at these distances, you can't really tell what things are next to each other and what things are super far apart from each other.
Perception. Yeah.
The depth perception, exactly. So, but these other four galaxies are really interesting because they are all interacting and colliding with each other. And with the Webb, we're now able to see in through the gas and dust clouds that are surrounding these galaxies because of the infrared light that Webb is able to pick up. So we're able to kind of see the interior of these things for the first time. What's interesting to me is we also have a galaxy that we are in galactic lockstep with, that is the Andromeda galaxy. And right now it is it's hundreds of millions of light years away, but it is heading towards us. And in 4 billion years, the Milky Way galaxy is going to collide with Andromeda. And actually, Andromeda is much larger than we are. And so it is going to create a massive spiral mess in a few billion years, which is really will be fascinating to see if humans are still around then. But this is kind of a good example of what the crazy swirls and offshoots and arms that get spun out when two galaxies interact with one another.
And it's just because there becomes like a conflicting gravity and things like that. And is that the primary reason behind the mayhem?
Right, exactly. It's these two massive galactic centers that have black holes in the center of them are going to be coming very close to each other. And so when that happens, the gravity gets so high that it'll just start flinging things off, and entire arms of a spiral galaxy will get spun out into space, and other arms will get sucked in. And it's really fascinating to see. And the quintet here is kind of a great example of how those are occurring, and we're now able to actually see inside of those arms that are being so heavily impacted by the gravity.
So this is going to be good to know for us in about 3 billion years.
Exactly. It'll inform our ancestors, our future humans that are hopefully still around. The sun might explode around that time too, so we'll see which one happens first.
There's no way I'm going to be alive then, I don't think. Unless there's major advances. But who would want to be alive for 3 billion years, for God's sake?
I mean, it'd be pretty cool to see Andromeda colliding with the Milky Way. I'd be willing to do it.
Be a good way to go.
Yeah, exactly.
And then your glasses get thrown off like billions of light years away.
Right. The black hole just suck everything out of here.
Right. That's cool. So that was the Stephan's quintet. That's 5 galaxies intermingling. It's almost like these are 5 new friends, that I don't know. It's hard for me not to think that even this is inside of a much larger body of something in infinitum.
Yes, right. I know it's such a gorgeous photo, and it really almost feels not real when you look at stuff like that. And the detail that Webb provides, you can pick out individual stars in these galaxies, and it's just fascinating to see.
It's also crazy to see how large they are, because you're saying the 8-point looking things are because those are kind of between us and the image we're taking, because those are in our galaxy, in our
right.
Yeah. And then those are just dwarfed, despite them being so much closer. They're dwarfed by the size of all the rest of the Stephan's quintet.
Yeah, absolutely. They're massive objects, hundreds of thousands of light years across, but they're millions of light years away from us. Whereas our near stars are, within 100,000 light years or so of us. Perhaps even significantly closer than that. The nearest star to us is about 4 light years away, which is right on our doorstep, astrophysically speaking.
Yeah, it would still take forever to get there, but I need more. Next. This is like the star death one.
Okay, the Southern Ring Nebula, right? So this is a planetary nebula, which is one of the most annoying misnomers in astrophysics, because it really has nothing to do with planets. But when they were first discovered, astronomers thought that it was like a planetary ring around a star. But really what this is a dying star off-gassing a lot of its mass, like right at the end of its life. So they anticipate the sun actually doing this, like I said, in 3 or 4 to 5 billion years potentially. But so this is a really interesting photo of that time period shortly after the death of a star and what it kind of looks like. And these don't actually last for that long. Like this will dissipate in tens of millions of years, something like that, even less, which is again pretty short time scale. And what's really interesting about this particular one is that it's hard to see, but it's actually a binary star system. So there's two stars in the middle of it, and the one that is smaller and dimmer is actually the one that was the one that off-gassed all of its content, which is why it's now just a dwarf. It was a red giant prior to this.
Okay.
Really interesting.
So the one that I'm looking at right now, Kevin, has like two different images of the same event.
Mhm.
Is that just filtered, or is that like a lapse of time?
So those are, depending on exactly which one you're looking at, I believe those are two different versions, two different cameras actually being used to take the photo. So in different infrared wavelengths. And so with the mid-infrared, you're able to see more through the dust clouds and the gas, and you can actually see deeper into the center of this versus, something that's more visible or in the near infrared will have more trouble seeing through the gas and dust.
Okay. Yeah, so this is just only a 10 million year process, so we were lucky to have caught it, I guess. Really,
Exactly.
probably unlikely that at least the humans as we know ourselves will be around in 10 million years, but who knows? So do
If
we
they're around in 4 billion years, they'll get to see the sun do it. So
exactly? That'll be a great day. Is this the beginning of the death of? I mean, I know it's hard to even fathom because the length of time
yeah.
is so massive. But like, is this something that just recently happened in space terms, or is this kind of a?
Yeah, it is. It's relatively recent. I don't know the exact number, but I would estimate probably in the last few million years that star released all of its gas. Like it reached its stellar ending, and it didn't go supernova because it's not large enough. So we all know the term supernova, which is like the explosion of a star. Generally, a star needs to be more than like 8 solar masses to do that. So this one was less than that. And so instead of exploding, it just kind of like it it blasts off its external content, but it doesn't actually like explode. So this probably happened a few million years ago. I'd have to look it up to figure out exactly if the scientists know, but still a really fascinating photograph.
Yeah, and so what happens after that 10 million years or whatever? What is there still a mass or like a really dense mass left, or does it actually eventually like go away completely?
Yeah, so there's still going to be a white dwarf there burning for a long time, but the surrounding gas will kind of no longer illuminate, and it'll kind of just float off into space, and so it'll end up just looking like a little star, or I guess in this case it's a binary star system. So you'll see just like two stars orbiting one another, which is pretty common in the universe. But we just caught this special moment where we're seeing sort of the aftershock of this off gassing of a dying star.
Crazy. It makes these pictures have an overwhelming ability to make you just feel tiny.
Yes.
I think maybe that's the appeal for me. It also looks a lot like grapefruit or something. This one.
That's
Yeah.
true.
Okay, so let's move. Let's move. I want to see this water. Let's go to this water.
The Wasp 96b planet.
Yeah.
So it's not quite as beautiful as all of the other photos because it's just a chart and everyone's seen enough charts in their life. But the beauty behind this is really a technical demonstration of the Webb, in that it really lets you see. This chart is kind of showing the spectra of an atmosphere of a planet around another star. This planet in particular is massive. It's about half the mass of Jupiter, but it orbits its star every 3.5 days. So it is very, very close to its star, but it's still very large. And we don't have any a planet like that in our solar system. But what we can do with the Webb now is not only see the starlight, and we can also see the planet move in front of the star. And so when the star's light dims, we know there's a planet there. We did that back in 2014, so we're well aware this planet exists. But now with Webb, we have such high precision that we can see the light going through the atmosphere around the edge of the planet and then hit Webb's receptors. And so we see the starlight go through the atmosphere. We can use spectroscopy to break apart the light and understand what exactly it was absorbing the light through the atmosphere. And that tells us the composition of the atmosphere. And this is really the first time we've been able to do this with Webb, and it actually demonstrates that there is water vapor in the atmosphere, and they believe that it is like a cloudy haze of water around this giant planet, which is just so fascinating to me. And one of my favorite parts of astrophysics is exoplanet research and trying to identify planets that could harbor life. And this planet probably couldn't, just because it has such high gravity and is so hot. It's 1,000 degrees on the surface, but still the fact that a planet like that has water in its atmosphere is just incredible. It's indescribable, and it just tells us that there must be water littered throughout the galaxy. And so there's probably other planets that are a little bit smaller, a little bit further away, more rocky, that also have water like our own, and who knows what's there.
Is there a chance that Earth will just continue to heat up through the way it's built or something, or because of the galactic forces? Is it possible that that would happen, or is it pretty much always going to be, as long as it's around, it's going to be the general same temperature, and it would basically, not change over time too much?
Yeah, overall, based on just the current distance from the sun, we're kind of at a limit of how hot it can get. It can certainly get hotter than it is now, especially with atmospheric conditions changing, I guess we'll say. But we'll never kind of get to the point where we're at, hopefully never get to the point where we're at 1,000 degrees. Venus is an interesting thought, though, because Venus has kind of a runaway greenhouse effect going on, and it is 800 degrees. It's quite a bit closer to the sun, but it has just an absolute crushing atmosphere above it, and it is extremely hot. It's extremely inhospitable, and Venus is still technically within that Goldilocks zone where liquid water could exist based on the distance to the star, but it has just had this runaway greenhouse effect. The planet that we're looking at, WASP 96b, is just so much more massive than Earth that we would never, become anything quite like that. But it's still interesting to see that water can exist in that type of environment.
I mean, so this had to be one of the this had to be one of the points to why they wanted to put Webb out there, if this was something you'd already studied. And yeah.
Yeah, Webb has a few different goals. One is obviously looking at the earliest universe. Another part is seeing through the gas and dust into galactic formation and stellar formation, which we've kind of talked about. And then this is seeing distant planets around in other solar systems, and what the atmospheric conditions are. And in a perfect scenario, it could detect potentially life indicating compounds in these atmospheres. So there's a chance that it could, but even if it doesn't, we can still see so much. We can learn so much more about these planets.
It's crazy that the resolution or the power of the telescope is enough to what material the light's bending through it. So it's crazy. It's like crazy, dude. I mean, these could all be fake. I think you're from NASA. I think you would validate that they're not, but I'm sure there's some crazy people out there suggesting that they are, because it is
They are not fake, but I can totally understand how it looks more like a computer simulation than the real universe. We're so used to Hubble, and if some of us remember prior to Hubble, that we really didn't have a lot of great detailed images of the universe. And then Hubble came along and kind of rocked everybody's world. And then this is just a next iteration of that, where we're having to rethink what the universe looks like because of the detail and clarity that we're getting from Webb.
Yeah, dude. It's just, man, it's crazy. Now we're going to go to my favorite picture. All right, let's go to the Carina Nebula. First off, shout out to my friend Mike and Natalie. Their daughter's name is Carina.
Beautiful name.
Yeah. So I was excited to send a picture of this to them. But yeah, so this is just such a high resolution. Man, tell me about it. What are we looking at here?
Yeah, so this is also kind of colloquially known as the cosmic cliffs. It's a roughly 7 light year tall, I guess tall is relative, but massive wall of gas and dust that we can see extremely clearly with Webb. Hubble also took a similar photo, so it's a really nice comparison tool. But Webb can see things not only more clearly, but also can see through a lot of that gas and dust that was clouding Hubble's vision in the past. So you just get so much more clarity and can see the stars inside of here. But this is really a nebula that is forming new stars right now. It's just a mass of gas floating out in space, and gravity is starting to pull it together in certain areas. And as it starts collecting, eventually there's enough hydrogen there that it starts a nuclear fusion process, and then a star is burning. So it's really just like an incubator for new stars, but it's just absolutely gorgeous to see in this light, in this depiction, especially through the infrared wavelengths.
Yeah, I think I see Jesus in here. It actually is like a very
You could certainly see a lot of things in there. So this is about 8,500 light years away. So it's pretty far relative to some of the other photos that we looked at.
yeah.
This is, of course, still within the Milky Way galaxy, but it's so massive that it just looks huge to us, and it does look like mountains painted over a starry night. But it really just is a massive stellar nursery that is a nebula.
This thing's just pumping them out.
Yes.
So it's traveling fast enough that when each of these ones is born, they're not like on top of each other, or are they ever having twins? Is what I'm saying.
Sometimes, like I said, we do have binary star systems, so they could be forming close enough that they're like in gravitational sync with one another, and so there's the gas and dust kind of starts swirling and perhaps clumps together. But again, we're kind of learning how stars are formed with this new technology. So we'll hopefully know more about how nebulas can birth stars. But yeah, it is just a matter of gravity kind of coming together. And once you get to a critical mass, a switch is flipped, and a new star has been born.
A star is born. Beautiful. This is beautiful, man. And so, can we expect to get like new awesome photos? There's more of these, by the way, people. I'm gonna run some more of them while we're playing out. But are we gonna get a lot of these?
Yeah, hopefully the floodgates are open. I just looked it up today, and the bit rate on James Webb back to Earth, despite it being 150 million miles from us, is still about 28 megabits per second. So probably better than some of the internet that some of you have listening to this right now.
Yeah, that's
Um,
better than what we grew up on, right?
Yeah, way better. There's no dial-up here anymore. And it is just pumping back data and imagery right now. There's some processing time with it because it is all infrared. It's no longer really picking things up in the visible light spectrum. So you have to kind of interpret the data and translate it into a visible image. But I'm sure that Goddard already has a lot of this, and there's already new science that's being done every single day. And we should be continuing to get these, and they'll get just more and more incredible, and we'll be discovering so much more. There's already papers that are coming out of these first 5 images. So I can only imagine what the next few years are going to bring.
Yeah, and I mean, do you know what the budget of this project was in terms of the actual like hardware componentry and all that?
Well, I know the total budget was about $10 billion for everything. That includes the research, the design. So much of the technology had to be invented, the launch system, everything, which is a lot of money, of course, but it has been a massive success so far. And the science and the data that we're getting back, in my opinion, is worth every penny. Of course, people can argue that, but
Oh yeah,
it,
I was gonna
yeah,
say it's relatively cheap when you consider the amount of information you're gleaning from it, right? Yeah. And it's like you said before, it's going to drive a lot of consumer technologies off of the developments that it had to do anyway, probably too.
of course. And it's here just to inspire. I mean, it is, if nothing else, you can look at these photos and you just think exactly like you said, like, what is my place in the universe when I look at something like this that is so beautiful, so far away? Why does that exist? And we're just now, getting a chance to see it. What does that mean? What is our human's place in the universe? And that really is that inspiration. And I was inspired by Hubble 20 years ago, and seeing those photos, and here I am now. And so hopefully the next generation will see these and think up an even better telescope to see even further, see even more detail. So it really is an amazing human achievement, in my opinion.
Yeah, this is cool. This is cool. And to think we were using those disposable cameras like 15, 20 years ago as a wedding.
Exactly. We've come a long way. Yes, this is I guess it is a disposable camera after 20 years, but it's a pretty massive one.
Yeah, it's like the size of what, like the Ford Field or something?
Well, the sun shield is the size of a tennis court.
Yeah.
And yeah, the mirrors, I don't remember exactly what they are. So I have this little image for those of you watching, but it's an example of mirrors. And these are all gold plated mirrors. I think it's about 25 feet wide. So it is pretty large.
Yeah.
And we hope it will be living. It was originally planned to live only about 5 years before it ran out of fuel. But because of how great the launch went, it could go up to 20 years. So we could have this for a long time doing a lot of science, which is so awesome.
Yeah, well, so let's talk about this from a personal perspective too, like as it pertains to your job, your responsibilities at NASA. So you're responsible for kind of safety systems, right? Or yeah, so were you involved like specifically on anything with this? Did you guys try any new software or anything that like went well? If the launch went well, that's a good thing.
Yeah, my job would have gotten a lot worse had the launch not gone well, because we do a lot of the management of the mishaps and investigations and trying to mitigate stuff like that. We do a lot of safety. So my organization is a safety and mission assurance organization. So some of our team members were down at the launch site, keeping track of the spacecraft before it was launched, and just trying to keep obviously people safe, maximizing the opportunity that it would be successful. So a lot of what we do going forward now is really planning future missions, making sure that they are meeting the requirements that are set out for them to be successful, and mitigating risk when is necessary and accepting risk when is necessary based on the cost and budget and schedule and things like that. So we're really trying to just make sure that future missions are safe but still achievable within a reasonable amount of time and budget.
Yeah, so the morale must be really high on NASA right now, right?
Everybody is pretty pumped, that is for sure, and there's so much more to come, and we're very excited. But it's always great when a mission like this goes very well. And I think back to like the Mars rovers, where no one really, the general public didn't really know what was going on until one day, oh my gosh, we've got a rover on Mars, and they have all these amazing photos and they're doing amazing science, and it captures the public's attention and wonder. And I love it when these type of scenarios happen, and I'm looking forward to more in the future.
Yeah, for sure. So what's the next one that's kind of got your not necessarily what you're like looking at in the near term, but like what's the next big project that NASA will be rolling out? I know we talked a little bit about these last time, but is there anything
Yeah.
kind of give a quick rundown on what's coming up, like a synopsis of that, and then maybe there's something else coming around now too that we didn't talk about.
Yeah, so we definitely touched on Artemis a little bit, which is the humans return to the moon. So again, I think this is another scenario where people don't really know how much work is going into that right now, but we're hoping to land humans on the moon in the next few years and also put up a space station around the moon, which is really fascinating. And the first woman on the moon, the first person of color on the moon, and we're going to stay. We're not just going there to land and then return home after a few days. So a lunar base is in the plans. Like I said, a space station is in plans. All of those things are happening soon. And the first launch, the test launch, was hopefully going to happen this spring. It's now got pushed to, I think, the end of this month. So we should be seeing that very soon, which is exciting. Beyond that, there's a couple awesome missions that are happening. I think the Mars sample return was just officially announced the other day, which we've been collecting samples on Mars for a while with our rovers, and now we're actually going to go get them, and we're going to send a mission there that will have some helicopters, and it'll go collect these samples, bring them back to a launch pad, and then send them back to Earth. And that is just so crazy cool to me to think that we can do that on another planet.
And is that whole mission unmanned?
Yeah, that'll be an unmanned mission. I think it's launching. I think they're planning on launching it in probably 4 or 5 years. That will be really cool to see. There's also the Dragonfly mission, which is actually sending like a drone to Titan, which is a moon of Saturn that has, we hope, liquid methane on it, but it is a really interesting planet. Kind of has some similarities to Earth, and at least the early Earth. So we could learn a lot about early life there. And then there's also the Europa Clipper, which is another satellite that we're sending to Europa, which is a moon of Jupiter that has what we believe to be liquid oceans underneath some ice. And so we're going to fly around it and see if we can catch any of that that water that's off gassing out through the planet into space. And we could even potentially detect microbial life or the building blocks for life in some of those geysers that it picks up. So that's another really exciting one. So there's so much going on that is related to the search for life and expanding our knowledge of the solar system that I'm really excited about.
Yeah, dude, I can feel it. It's super crazy. We're gonna be yeah, we happen to be alive during the generation where like the technology is growing so fast that it's like things that we never really even could have considered before, and are just, even though we're only in our 30s, stuff that I never would have considered as a kid is like happening now.
Yeah, and hopefully, I think the person that is the first person to walk on Mars is alive right now, and I don't know exactly when it's going to happen, but it should be in our lifetimes, and they're already working on it. What we're proving out in the moon missions is really part of it is a technical demonstration on how do we do this on another planet, and that's I will retire happy if we can get there.
Yeah, and then you can go move in with Bezos up there when you're ready.
Yeah, exactly. We'll hit the space hotel.
Well, Kevin, dude, I appreciate you spending some time and lending your expertise. This is like, I know we could have probably discussed each one of these for an hour, but I think this will at least give people a quick education, and then you can, folks go learn more on your own.
Yeah.
Yeah. Where is there a lot of good literature already like posted on at nasa.gov, or where do you?
Yeah, definitely. NASA has a lot of great resources on their website. James Webb has a specific website. We can post those in the description if you want to learn more about those. And certainly every major news outlet is covering a lot of these, which is really exciting. But there is so much more to learn, and every day new science comes out. So if whatever you learned last week there's more to learn this week for sure.
Oh, well, I have one more thing I need to learn. So if it's 28 megabytes per second, how long did it take? Like, how long did that transmission take to get that first image? Like, I guess we could probably have to do some math.
Yeah, that's a good question. It took 12 hours to photograph. I'm not sure how big it is, but they get about 55 gigabytes a day. So I don't think the image was 55 gigs. So I think that, they're able to get that down faster than they can take it, which is really important then. So you can just continually take photos as fast as you can and you beam it back to Earth. And then there's a process of kind of stitching them all together to build out those photos. But that can be processed on the Earth side. So it really, the technology and the communication technology is just fascinating to be able to get that stuff back that quick from that far away.
Yeah, listen, Comcast.
Exactly.
Acceptable it is. That drops out every fucking day. So, oh, dude, thanks, Kevin. Let's be in touch again when there's another. There's going to be a bunch of more of these, so we'll do another one of these in a couple months. When, who knows, maybe we will have found our multiverse of parallel universes of people that look just like us but are slightly different accent or something different. No beard. There's a Kevin somewhere with everything's exactly the same, but there's no beard.
Yeah, when we find him, let me know, and I will happily come back and talk all about it.
Okay. All right. See you, buddy.
All right. Thanks a lot, Kurt.